In this lesson, we will be talking about patterns and relationships in tables. So what I have here is an input-output machine. What happens with this is we put something into it and it spits something else out. Now, this one works with numbers, but it could work the same if we think about it like a candy making machine. If I take sugar and color and flavor and I put it into this side, the machine's going to work its magic and it's going to spit out a candy on the other side. And so the same thing works with uh, math and with the expressions and relations. And we're going to take a look at how that sort of works out. So it relates n to 2n plus 3, this specific machine. And it does that to create a table of values. And so we select a set of input numbers. I always just choose 1, 2, 3, 4, 5 because those are typically the numbers that are easiest to do math with. And what happens is I'm going to plug n into this side, and I'm going to start with n equals 1. So I'm going to put the number 1 in, which means I'm going to substitute 1 into my equation, so this 2n plus 3. So 2 times 1 is going to give me 2, and this plus 3 is moving down. And then 2 plus 3 is 5. So when I put 1 into my machine, it spits out 5. If I plug 2 into my machine, I'm going to go 2 times 2 gives me 4. Add that 3 is 7. So if I plug 7 into the machine is going to spit out 7 once it's done. Same thing goes for 3. 2 times 3 is 6. Add that 3 is 9. If I plug 3 into the machine, it's going to spit 9 out the other side. So I can plug any number I want into the machine. The machine will do the math, or in this case, we will do the math, and then we can determine what the machine would spit out. We used consecutive input numbers. So we will always use these numbers 1, 2, 3, 4, 5. Consecutive means in a row. The output numbers form a pattern, and they increase by the same amount every time. So 5 plus 2 is 7, and 7 plus 2 is 9, and 9 plus 2 is 11, and 11 plus 2 is 13. So when we have this, it shows us that we can actually write this as an expression, and we have that 2n plus 3, and it has that pattern in there. So these patterns are important when we are talking about expressions because they do tell us different things about them. When a relation is represented as a table of values, we can write the expression or the relation using algebra. So I have done this equation here for you, this example, but I'm going to go over to the whiteboard to explain it a little bit more step by step so that you can see how I would do it and hear my thinking process with that.
This example asks us to write the relation represented by this table. So in order to do that, what we're going to do is we are going to determine some of the patterns that happen within the table. So the first thing I'm going to do is I'm going to look at my inputs and I'm going to determine how does this change each time. And so I know to go from 1 to 2, I'm going to add 1. And to go from 2 to 3, I add 1. And 3 to 4, I add 1. And 4 to 5, I add 1. So I'm going to add 1 every time in my input column. In my output column, I'm going to be adding 3 to get from 2 to 5, 3 to get from 5 to 8, 3 to get from 8 to 11, and 3 to get from 11 to 14. When we do this, we can use this understanding to help us write the relation for this. So we know that this is our n value. It sort of represents what we're going to be plugging in because it's our input. And so we can come up with the pattern. So whatever we are going up by every time here is actually what we're going to multiply our variable n by. So every time it goes up, I'm going to have 3n. So whatever this output changes by is what I'm going to multiply my n value by. Then I need to do a little bit of figuring and determine because this may or may not be the full answer. So if I plug in 3 times 1, I get 3. But that's not my output of 2. So I know I need to do something to get to 2. And the first thing that I can think of is to subtract 1. So I'm going to try this with a couple of the others. So 3 times 2 is equal to 6. Well, that's not my value of 5, but I can subtract 1. 3 times 3 is equal to 9. I need it to equal 8, and I can subtract 1. So every time after I do my multiplication, I'm going to be subtracting 1. So that tells me that my relation should be 3n minus 1. Now, I left 2 here because I would like to test them and make sure that my equation is correct. So I can say then that 3 times 4 minus 1. 3 times 4 is 12. Minus 1 gives me 11, which is what it says I should have here. And I can also do 3 times 5 minus 1. So 3 times 5 is 15. Minus 1 is 14. And again, that is where it is located here. Now, this is the easiest way that I usually use to determine a relation. There is another solution in your notes that you guys can read through and see if you like that way more. That one doesn't always work. This is a setup that will work every time we are given a question like this.
With your practice questions, we have a variety of input and output machines or tables. So you're going to have to show your work for each one of these steps in this one. Please make sure that you are showing your work on a separate piece of paper or down the side. I don't know if you'd have enough room to do it on the side because the steps on the paper are actually the more important part than the actual table. So I want to make sure that when you're doing this that you have a good idea of how you will manipulate these equations. Some of them are asking you to come up with the actual relation, so that would be the second 2. And then there's also a reflect here to sort of get you to think about this in a different way and see if you can explain how to do this back to me, which is a really good gauge of whether or not or how deep you understand the concept.